can. Please have your questions ready. Today's lesson is going to be a continuation of chapter 4.2, and I am going to ask, I'm going to go through a bunch of examples, try to get through as many different types as possible. And a lot of you will probably start to see a repetition or a pattern of how to do these kinds of questions, and hopefully at the end of it, you understand why or how CAST rule it works and how you can apply it even in ways that we don't cover today. Okay? And the goal is you will be able to do all the questions that I have assigned through the sheet and then some. Okay, you may have also noticed that we have a quiz on our Google Classroom that is covering chapter 4.1 all the way to 4.3, including today. It has a whole bunch of stuff on, special triangles, 30, 45, 60 degrees, cast rule, and the like. All right, so let's get started. You may want to sort of copy this down if you want to. If you don't, that's fine as well. But I'm going to use this to sort of solidify why and how cast rule is helpful. Okay, let's get started. Someone using their special triangles should be able to tell me what sine 30 is equal to. And by sine 30, I am talking about this terminal arm right here. Okay, I don't care about the actual xy point. It's just that terminal arm creating this angle right there of 30 degrees. What is the sine ratio for that triangle? Come on, special triangles. You should know it. If not, you can look at the sheet. Sine 30 is equal to, thank you, Kinda, 1 over 2. And that's all there is to this question. But what if the same question asked for sine 150 and the condition is no calculators? Okay, like what is that equal to? Of course, you can plug in sine 150, but that's not the point. And the reason why I'm asking you to explore using cast rule is because when you do it in reverse, the calculator suddenly becomes limited. And you'll see some of the examples we get to today. Right? So what is 150? And this is what's happening. 150, if I draw, let me try to draw this in, let's say, red. If I draw a terminal arm that extends 150 degrees around the origin in standard position, I get that as my terminal arm. And you know what? It's an angle that is outside of 0 and 90 degrees. We haven't really explored that. Maybe in grade 10, some of you might have thought, oh, can I use sine law, cosine law, whatever? Um, you could try, but there's actually a really efficient and effective way to solve this. An angle of 150 on a Cartesian coordinate in standard position creates the exact same shaped triangle, but mirrored on the other side of the y-axis. In other words, it is congruent, but just flipped, right? So this is quadrant 1, remember, but this is quadrant 2, where any angle that is between 90 and 180 degrees fall under it, right? And again, I'm also going to allude to a previous lesson. This angle of 150 degrees, I can pretend that the interior angle of that imaginary triangle is going to be 30 degrees. So again, what is sine of 30 degrees? So in other words, what I'm trying to say is the angle of 150 is equivalent to creating a 30 degree triangle. 30 degrees, 90 degree triangle. Right? So essentially what I'm saying is sine of 150 is equal to the same as sine 30, which is going to be 1 over 2. Okay? I'll continue on. Sine of 120 is basically saying sine of a full 180 degrees plus an extra 30 degrees. Okay? So this time I'm going to take the blue and let me draw a picture. Of course, this picture is definitely not to scale, okay? Sine of 210 degrees is that. But an angle of 210 degrees, I can create a triangle with an interior of 30 degrees in the third quadrant. So again, if I'm dealing with a triangle that has an angle of 30 degrees, what is, again, sine, opposite over hypotenuse, y over r? What is sine of 30? Well, it's 1 over 2. But stay tuned. There's something that I'm going to add to this, okay? And lastly, the same triangle, the grayed out triangle that I drew, if I rotated 360 degrees, let me use a different color. That is the same as me saying, I want to rotate a full 160 degrees, but I'm going to leave the 30 out. Okay? This is sort of like saying this triangle. I've rotated, oof, let's see if I could do this nicely. I've rotated a full 330 degrees. In other words, it could have been 360, but that interior angle right there is 30 degrees, right? Sine 330 gives me the same terminal arm as if I was rotating 30 degrees on the other side. And so sine of 330 is basically the same as saying, what is sine 30? Because you draw the same triangles. So it should be 1 over 2. I'm going to put another star next to this one. Remember, think about it, sine of an angle is opposite over hypotenuse. In a Cartesian coordinate, opposite can be rewritten as the y value, the height, I guess, and h is the radius. So y over r, every single time I'm just putting the y over the r. So that's why we have, this y value and this y value are exactly the same in terms of the actual length. This y should also be equal, and this y should also be equal because they're all the same triangle. The only difference is in quadrant 3 and quadrant 4, the y value is a negative. So it's actually a negative valued y over r and a negative value y over r. If I'm doing the sine value in the third quadrant, and if I'm doing the sine value in the fourth quadrant, it's not quite equal to sine 30. I'm going to put this in quotes. The absolute value is still the same, but we have to remember the y value in the quadrant 3 and 4 are negative, and so we have to stick that negative there. And this is cast rule. I don't want to deal with all of this, right? As a mathematician is just a little bit annoying. I'd rather not have to worry about y and r and y and r every single time. So this is the cast rule shortcut. Let's use pink. C, let's get bigger, thicker. C, A, S, and T. If you know that you're in quadrant 1, that's 30 degrees. Every single ratio, every single ratio is going to be positive, and so it's going to equal a positive half. If I'm dealing with sine 150, that is quadrant 2. So go to the Cartesian coordinate. In quadrant 2, only the sine value is positive, and therefore we have a positive half. When I'm dealing with sine 210, I know that I'm dealing with an angle in quadrant 3. So jump over to the Cartesian coordinate and look at quadrant 3. only the tangent ratio will give you a positive value. And so my sine 210 must be a negative half. Okay, quick recollection. It's half because it's basically creating the same triangle as here, but it's a negative because it's in quadrant 3. Lastly, an angle of 330 tells me I'm in quadrant 4. So I'm going to take a look at my Cartesian coordinate. Quadrant 4 tells me only the cosine value is positive. So my sine 330, which is supposed to be equal to sine 30, has to be a negative value. This is Castro. Again, this might be a little confusing. So let's try some questions. Before we get to those questions, I want to bring a little bit of an attention to this. Notice how 30 degrees, 30 degrees, 30 degrees, and 30 degrees, every single one of these triangles had an interior angle of 30 degrees. Long story short, the angle that we use for quadrant 1, we are going to essentially pretend it's the same angles here. The 30 degrees is called a reference angle, or a textbook can also call it the related angle. My pen. Related angle, and we use the term theta little r for the related angle. So the angle at theta little r is 30 degrees. This means the angle that I'm dealing with in quadrant 1 is the same thing. The angle that I'm dealing with in quadrant 2 is, if this is the 30, then the angle I'm dealing with would be 150. The angle that I'm dealing with in quadrant 3 is 210, and I didn't give myself enough space. And the angle that I'm dealing with in quadrant 4 is 330. Is there a way that I can write a general formula for all this? Yeah. For quadrant 1, the angle that I'm dealing with is the same as the reference angle. In quadrant 2, if you want to find the angle in question, it's actually 180 subtracted by 30, the reference angle. Quadrant 3, that is actually 180 plus 30 degrees. That's the reference angle. And quadrant 4 is 360 minus 30 degrees. 360 minus the reference angle. I'm going to take 3 minutes. Some people can ask questions if they want to. Other people might be busy copying. I'm going to start some practice questions at exactly 2:20. Are there any questions you would like to take? Or questions you would like to ask? And if you don't have any questions, I would like you to look at what we wrote here, try to let that sink in, and maybe think of some questions that are confusing, that would clarify some confusion that you have right now. Some of you might have already checked it. It seems confusing, but you'll be able to figure it out after some of these questions. It's very, very straightforward. While that's happening, someone remind me, how far did we get into 4.2? So we covered coterminal. Which question did we not do yet? Number 3 on second page is where we left off. Oh, we did a lot then. Let's revisit if since we've done number 1, A and B on the third page. Oh, wait. Number 3 on the second page is where we left off. Okay, perfect. The question 1 on the third page, so example 2, cast rule and related angles, that will give you a really good demonstration of how we can use cast rule. Okay? All right, let's clear this. I'm going to start with a new page. Everyone, you can follow along with question 1A. So question 1A says, use a calculator to determine two angles associated with cosine theta equals negative 0.627 for all angles between 0 and 360. Okay, at this point, I'd like everyone to go dig out your calculator because I want you to see this and understand the impossibility of answering this question with just your calculator. Okay? Would someone use your grade 10 skills, do the inverse of cosine to figure out what the angle must be to give me a ratio of negative 0.627? All right, Waylon's got it. Everyone else, hope you agree. 128.8 degrees. Okay? Which means, which means the angle that we're doing right now is, remember, that would be 0 degrees, this is 90 degrees and 180. So I'm hoping that it's automatic. You know that the angle we're dealing with is around here, closer to 90, further away from 180. This is 128.8 degrees. So what quadrant is it? Quadrant 2. Okay, so the first angle that we're dealing with is, um, so I'm just gonna, for the sake of simplicity, I'm gonna write angle in 2 is equal to 128.8 degrees. Okay, all right, everyone, use your calculator to find the second angle. Problem is you can't. There is another angle that exists that will give you a negative 0.627, but the computer cannot do it because it's programmed to give you the most efficient angle for that situation, right? Just like how your calculator, when you do a square root of 4, let's say, it doesn't give you plus or minus 2, it just gives you 2. It'll just give you the most efficient number, right? In the same way, there's more than one answer here, but the calculator won't be able to give you both. So how do we figure it out? Well, this is where cast rule comes in. If you have an angle of 128.8, what is my reference angle? So create your imaginary triangle. What is the reference angle that can be transferred over to all four quadrants? Yeah, right? So Nathan's got it. So here it is. One way you could do it just automatically, you're like, oh, okay, one full rotation is 180, and so I'm just going to do subtraction. Well, that's exactly what it is. In quadrant 2, if you remember, right? Quadrant 2, the angle is equal to 180 subtracted by the reference angle. So if you do your rearranging, if you do a little bit of algebra, you will find that, yeah, 180 minus 51.2 degrees gives me 128.8. So this angle on the bottom, so let me just highlight this so that you know where I'm talking about. This angle right here is 51.2 degrees. I'm going to take that and I'm going to apply it to all the four quadrants. But actually, in actuality, you don't have to do it all four. I know exactly which quadrant I have to go to, but you might not. Here's a clue. Cosine is supposed to be a negative value. Which other quadrant gives me a cosine as a negative? So cosine theta, cosine x, the cos ratio is negative. The only other angle, no, the only other quadrant that gives cos as a negative is, anyone? Can anyone pinpoint which quadrant I'm dealing with? You're like saying everything, Nathan. You're right the first time. Take a look. In quadrant one, every single ratio is going to be positive, so all, right? That's why the computer didn't give me an angle between 0 and 90. It's not here. I'm not looking for an angle in there. The second quadrant, only the sine value is supposed to be positive. And that's why it worked. Cosine here is a negative. That's the first time we'll see a cosine of the angle that fits this bill. The third quadrant, only the tangent is going to be positive, which means the angle that we're looking for that gives me a cosine value that's a negative is probably going to be in quadrant 3. And just to confirm, if you look at quadrant 4, it says C for cos. Only the cosine is going to be positive. So that angle cannot be in quadrant 4. The question says the cosine ratio is negative. Let me write this. Okay. And so knowing that, I am going to draw my triangle in the third quadrant. I'm going to tell myself that this is a reference angle of 51.2 degrees, right? And if that's the case, what's the original angle that brings my terminal arm to this point with a reference angle of 51.2 degrees? That's basically a full 180 degrees plus the extra reference angle, which gives me 231.2 degrees. And just to confirm, try it. Try cosine of 231.2 degrees. You should get the same negative value. Confirm, like I really want you to go through the motion and try it. Just give me a thumbs up if you've tried it. It also gives you a chance to test test your calculator. Oops. Oh, Mona, you made it. Here, let me fix the attendance. Mona, if you see the system calling you saying you were absent, that's because I submitted the attendance already. But you can ignore that and tell your parents or whatnot that it was just a mistake. I'm not seeing too much of a response. It might be because I've lost you um, on the thumbs up screen, but we'll try another one, okay? But this is essentially what it is. Every single question, um, give me a second. I'll come back to the whiteboard, but I want to. Oh shoot, what have I done? Oh, man, give me a sec. I meant to get to. There it is, and share that. Okay, everyone, going to our handout, every single question that we do, you will see me figuring out what quadrant we're dealing with, because it's really important to do so. You'll also see me, right? You'll also see me always calculating the reference angle, because then I can move between quadrants without any worry, and then apply a cast rule and figure out where the negative is supposed to be. Every single question, the reference angle I know will probably help me, so it's a good idea to try to find out. And also identify which quadrants we're looking for, because that will dictate whether it's a negative or positive. Okay, let's try. So we just did number 1A. Let's try number 1B. Use what we've just done for part A to identify what part B might be. Okay, I'll give you a bit of a head start. Okay, sine of theta is supposed to be negative 0.643. So what angle is that supposed to be? Hmm, close. Not quite 40. Yeah, if you look at the calculator, you might get something interesting. You get a negative 40 degrees. I'm just going to round it. And what does that mean? Don't be scared about the negative or think you did something wrong. A negative simply means I'm not going in the positive rotation direction. I'm turning 40 in the negative direction. That's all. So my terminal arm is actually in quadrant 4. So a negative 40 degrees is actually equivalent to a positive 320 degrees. Okay? So notice, if you gave me the angle of negative 40 degrees, right, it's not between 0 and 360. So we have to figure out equivalent angles that's between 0 and 360. And you know about, because you've learned about coterminal angles, negative 40 degrees and positive 320 degrees are exactly the same. So I'm going to use this drawing right here to determine that, okay, in quadrant 4, the angle that gives me negative 0.643 is 320 degrees. Okay? So unfortunately, this does not give me two angles. So the calculator again is limited. What do? Well, we got to figure out what quadrant we're dealing with. Number one, yeah, let's figure out what quadrant we're dealing with. The sine value is negative. Therefore, the theta, the angle, must be in quadrant 4 or which quadrant? Where else in this Cartesian coordinate plane gives me a negative sine value? Yeah, there it is. Okay, okay. So let me update this drawing here. That means my terminal arm must be somewhere here. But I don't know what that angle is. What's my reference angle? Trick question. This part already gave me what the reference angle is. Consider this. If I take this negative 40 degrees, it's actually at exactly the location we would have drawn a congruent triangle. Like I would have drawn another triangle right here, another triangle right here. That negative 40 degrees happens to overlap with where my reference angle would have been. So this reference angle is going to be 40 degrees. In other words, this part is going to be 40 degrees. And my reference angle is 40 degrees. I'll stop right there while people catch up. Does everyone understand how I can just say, oh, the reference angle must be 40? Okay, once again, the question, when we plugged it into the calculator, the angle was supposed to be negative 40 degrees. So that's what I did. I rotated in the negative direction, and that was my negative 40 degrees, right? But if I were to draw out my imaginary triangles so that I can use cast rule, the angles that I'm interested in are here, 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 and here, right? Well, tell me, what angle is it? Yeah, right? So for this one, the question gave me negative 40, but that angle of 40 degrees happens to be the exact same location we would have been looking for our reference angle. So at negative 40 degrees, remember the negative simply means the direction of rotation. The angle here, the pure value of it is just 40. So I know that my reference angle is 40. Okay, so I'm going to clear some of this stuff. I don't need it anymore. And now erase this and erase that. Okay, so if that angle is 40 degrees, because I know that the reference angle is 40, well, what is that total angle? Remember, you can do this by counting. This is 90 degrees, 90 degrees, and then an extra 40 degrees. Or you can remember that the angle in quadrant 3 is always going to be 180 degrees plus my reference angle, which is plus 20, plus 40 is 220 degrees. Therefore, sine of 320 will give me negative 0.643, and sine of 220 will give me negative 0.643. And this is something the calculator is not able to do. It will only give you the most efficient one, the one where I have to travel the least from the x-axis. But there's more than one possibility, and it's very important that you know that. I'm going to give it another minute. For those of you who feel like, I see repetition, I'm still a little shaky, I'm not quite sure, would you please go on ahead of us? I'm gonna leave this on the board until for maybe a couple more minutes. Would you please try to determine the exact value of this angle without a calculator? And the reason why I say you can do it without a calculator is because negative 225 happens to have a reference value of one of our special triangles. See if you can figure it out. The first thing you want to do is figure out which quadrant it is it? And number two, can you identify the reference angle? Because that will really help you figure it out. Like, and three, why not just draw or sketch out the Cartesian coordinate so that you know where the triangles are? Until you can visualize it in your head, always draw it. Give it a shot. I will start this question in about 2 minutes. Okay, let's try this. I'm going to clear here. All right. Won't need much space, as you can see. Let's take a look. Cosine of negative 225. Preferably, in my head, I would like to have positive angles, but let's figure this out. And let's make some neat drawings. Some of you might make best friends with your rulers in this unit. Cosine of negative 225 means I am rotating in this particular direction. That's a 90. That's 180 in the negative direction. So I need to turn just a little more. How much more? 45 degrees more. So let me make a nice clean drawing with the terminal arm here, which I rotated as 225, or you can say I rotated, so this is negative 225. I could say I rotated in the positive 135 direction. Either way, using this information, I know that the little angle inside that terminal arm that makes the angle with the x-axis is 45 degrees. So in actuality, this automatically tells you that the reference angle is going to be 45, and I could use that 45 to move anywhere in the quadrant. Yeah, okay. So in other words, so here's another way we can use cast rule. So basically what we can say is cosine of negative 225 degrees is basically creating the same triangle or the same ratio as cosine of 45 degrees, but in quadrant 2. So cosine of 45 degrees, let's figure out what the ratio might be if my triangle was in quadrant 1, right? And then once we figured out the ratio, we can apply it to quadrant 2. So if in quadrant 1, so I'll write if in quadrant 1, cosine 45 degrees using special triangles is root 2 over 2 using either the chart or the special triangles. But remember, since it's in quadrant 2 by cast rule C-A-S-T, sine is positive. So if cosine must be negative. Therefore, cosine of, I'm going to say negative 225 equals a negative root 2 over 2. Again, root 2 over 2 because same triangle as 45 degrees. By triangle, I mean literally right angle triangle. Okay, same triangle as a 45 degrees, and the negative because it's in quadrant 2. Always figure out what the reference angle is, figure out what quadrant it is, and it tells us so much. Each of these questions is just jam-packed with info. We have to just practice unpackaging it, and you'll see all the things that each question can offer. If you want to build a bit more confidence for the people who are done this question, try number 3B. The same idea. I'll move on in just a minute, so give yourself a chance first. Okay. Oh, I can't get any closer. Okay. Determine the possible measure of theta if sine theta is going to be a negative 1 over 2. Okay? The negative will tell me which quadrant it is, and the actual value will tell me what the angle could be, or rather, the reference angle is going to be. So let's take a step back. Okay? That might be just new information and you don't want to handle that right now. Let's pretend this angle was actually in quadrant 1. If that's the case, all values would have been a positive. So what angle gives me a sine ratio of 1 over root 2, spatial triangles, 45 degrees. If this was in quadrant 1, the angle would have been 45 degrees. In other words, this, honestly, like sine theta equals negative 1 over root 2 is jam-packed with information. You just got to unpackage it. If the angle we're dealing with was in quadrant 1, this would be my triangle and my angle would be 45 degrees. But because sine is a negative, what quadrant must it be in? C, A, S, T. Sine theta, the angle that we're dealing with, has to be in quadrant 3 and quadrant 4. So this part right here must be in quadrant 3 or 4. And this angle is our reference angle so that we can draw the same triangle in quadrant 3 and quadrant 4. So let me do that. Okay. And in your head, knowing that this is 45 and knowing that this is 45, I know it's a little small, but just bear with me. Maybe I can make it a little bigger. Oh man. Let's see if I can do this. Ooh, okay, okay. That's a little too big. A little too big. Okay, there you go. Knowing that this is 45 degrees all around, all it's asking is what the answer is. So if you have the reference angle, it becomes pretty straightforward. I'll use red. The first angle in quadrant 3 is right here. So quadrant 3, so I'm going to do theta 3, is going to be a full 180 degrees plus my reference angle of 45. The first angle that will give me negative 1 over root 2 is 225. The next angle I'll use blue is all the way around here, which stops me 45 degrees short of a full 360. So the theta, so what fourth angle, sorry, the angle in quadrant 4 is going to be not 360, but subtracted by the reference angle of 45 degrees. The angle that gives me a negative 1 over half is going to be 315. So what are the possible angles of theta that makes this true? Right here. Okay, so I started covering a lot of like example questions here. Does anyone have any concerns or want to clarify certain things? Seems everyone's okay or just copying or just trying to cope. Do we need the 180 plus theta r? No, if you can do it in your head, then that's totally fine. I just wanted to show you how you can get around it. What if like the reference angle was something obscure like 73 degrees? How would you know what the actual angle is? Well, just being able to manipulate with 180 or 360. It might come handy later on. That's all. It seems that it's either people are so confused that they don't know what to ask, or people are slowly trickling along. I'm going to ask you to take a look at the very last page. There should be a bunch of questions like this. If not, it's already online. I'd like you to try looking at, we're going to do numbers 4 and number 10 together. Again, it's not the only questions that I want you to focus on, but there's some good examples of how a single statement is jam-packed with info. Okay, so let's try number 4 together. Simon asks, is a special triangle chart that was done in class posted on the classroom? Um, it's actually part of your handout. If you take a look at your 4.1 handout, it's right on top. Oh, sorry, chart. No, the chart was something, it's very unofficial. It's something that I learned from school and from my sister actually, my eldest sister. And so it's not something that you would see in a textbook, but it's a little trick that happens to work, and so I memorized it. I offered it to you. You can take a look at the YouTube video. If not, just stick around at the end of class and I could rewrite it for you. Okay. But for everyone else, would you try number 4? This statement right here is jam-packed with info. You're able to answer this very easily. I'm going to share a whiteboard just to copy. So if cosine of some angle equals 12 over 13, what is tan theta in quadrant 4? That's the question. I'll just give another minute. See if you can try to pull out some information from it, or decide on what you might want to try, and then we can confirm it by doing it together. Okay, let's give it a shot. Here is what this simple statement actually carries with it, like the weight behind a single statement. If you recall, cosine theta on a Cartesian coordinate plane refers to x over r, remember, adjacent over hypotenuse, right? Another way you can think about it is, if this is 12 over 13, my x value being 12, my hypotenuse being 13, you can actually figure out what the y value is, right? That's one way you can approach it. So let's do it. Assuming that this is my triangle, you can actually use Pythagorean theorem. So that's my y. So 13 squared is 169, 12 squared is 144, and then y squared. To get y all alone, I'm going to subtract 144 from both sides, leaving me 25. So y must be 5. But actually, it could be plus or minus 5, and that's sort of interesting. Take a look. If I am dealing with tangent in quadrant 4, this same triangle I'm going to draw in quadrant 4. The hypotenuse is 13. My base, my x value is still at 12, right? So quadrant 1 and quadrant 4, they both give me a cosine value of 12 over 13. But my y value in this case is not a positive 5. It's going to be a negative 5. Like square root of 25 should be positive or negative. It just seems to happen to fit in this situation as well. So tangent of theta, you know it's opposite over adjacent, which is rewritten as y over x, which means the y value being negative 5, the x value back up here in the drawing, the x value is 12. Tangent theta will equal negative 5 over 12, and you did it without the calculator. Right? So just another recap. A simple statement of this not only tells you 2 of the 3 different values you need to know, you can actually figure out the rest, and using that, you can apply it to any quadrant you want. It just so happens the question asks for quadrant 4. That's all. Okay. Any questions here? Okay. Could we go back to the question sheet? Let's try number 10, because this seems to be a little bit different than what we're used to, but it's still the same general idea. Okay? Radius, that's a 3. Terminal arm, 30 degrees. What is the coordinates of this point P? Hmm. Well, in this one, you don't even have to do too much cast rule. Even a question like this, don't feel like you have to force your way into using cast rule. Maybe you would have to if I was giving you a question like if it was in quadrant 3 or something like that. But in this particular case, it's easy because it's in quadrant 1. You don't have to worry about negative values or anything. Remember that sine is equal to opposite over hypotenuse, or y over radius, which is y divided by 3. Also, you can use cosine to identify the x because cosine is opposite over hypotenuse, sorry, adjacent over hypotenuse, which is x over 3. Now you could go ahead and use the calculator, but unfortunately it won't give you the exact coordinate. 30 degrees, you should be able to um, use special triangles. So what is sine of 30 degrees? Half. What is cosine of 30 degrees? Uh, root 3 over 2. Now I can get rid of the fraction. I'm going to multiply both sides by 3, and I get myself y value of 1.5, or 3 over 2. I'm going to multiply both sides by 3 to get my x value of 3 root 3, 2. Therefore, my point is 3 root 3, 2, comma, 3 over 2, or 1.5. Any questions? Hmm. There's one less part. Did someone have to step out? Like someone might have stepped out. It's not a good look. Do I really have to go back and double check attendance? Stress. I'll get to it after. Okay, there's a lot of silence. Maybe you just want to try practicing it to really master your skills. Sorry to jump around. I'm going to go back to your previous 4.2. There was one question that I skipped and I didn't do. I want to get back to that. Okay, that is number 3A, just before the last question on the third page. For what values of angle is tan theta unidentified? Think carefully. There are many ways to approach this. I'll give you a hint. Tangent could be either be rewritten as sine over cosine, or remember, it could be y over x. At what angles would you have tangent undefined? I'll give you a minute, or rather take as long as you want, because this is how we're going to finish today. Okay, okay. Thanks, Zoe. Let her know she doesn't have to stress. Let her relax a little bit. She can uh, look at the recording after. I know very, very well, personal experience of how frustrating tech can be. Would cosine have to equal zero? Absolutely. So when does cosine equal a zero? Or rather, when is this denominator going to equal a zero? So remember here, let's pretend I'm using a unit circle. That's a 1, 0. That's a 0, 1. And that is a negative 1, 0. And that's a 0, negative 1. If you think about it like that, at what points do we have the x value equal a 0? Meh, meh. A 0, the point 0, 1 corresponds to an angle of 90 degrees, and 0, negative 1 corresponds to an angle of 270 degrees. So that's 90 degrees and 270 degrees, right? So that works. Try cosine of 90 degrees. You'll get a 0. And also, if you do cosine of 270, you will get a 0. And that makes sense for a variety of reasons. Cosine is equal to x over r, which is equal to x over r. If the x value is a 0, the fraction is equal to 0, so the answer is 0. In the same way, tangent is y over x. So any angle that has an x value of 0 is the same idea as the cosine. So there it is. The angles that make tangent undefined is going to be 90 and 270. I guess in recap, the variety of ways that you can approach these questions is what I think makes it difficult for a lot of people. Up until now, a lot of students have been looking for the one trick way or the tunnel vision way or step one, step two, step three to solve a question. For sinusoidal, now that we're looking at broader ideas and the universal sort of symmetrical shape of a circle, there isn't going to be just one step, two step, three step. You're going to have to look at it in a variety of different ways. Some ways are easier to solve a question than others, but it doesn't mean it's impossible. The more you expose yourself to different types of questions, I think the more flexible you will be in trying different, I guess, methods, trying different strategies. So that is how I'm going to leave you. Please try these extra past rule questions and use the quiz that's on our Google Classroom as practice to expose and to experience more varieties of trig questions. All right. Anything you want to erase or questions you might have? Pretty solid stuff. Okay. Um, next lesson in our trig unit is going to be sine law, cosine law. And I'm adding, so sine law, cosine law is something that you should know from grade 10. So I'm going to review it relatively quickly. And then I will show you the extra addition that you would have to know for grade 11. Hint, hint. Remember our little pep talk about the test? I am more interested in grade 11 material than grade 10. So you have to know your grade 10 stuff so that you can prepare and be successful, I guess, in tackling grade 11 material stuff. Okay, so that's my goal or my plan for tomorrow. Questions? Concerns? Okay. The remaining 10 minutes, I'm going to let students use it. They're going to let students use that last 10 minutes as a tutorial session or a place to ask questions or clarify. If you don't have any questions or you're eager to just, grind out some of these homework questions out, you are officially dismissed. Please take a break and don't wait until tomorrow to try some of these Castro questions. Okay? I will see you, I believe, tomorrow. And yeah, work hard. Bye, everyone.
Thank you, Mr. Kim.
See you later.
Mr. Kim, you don't need to redraw the chart. I'll just watch the video because like the first time I wasn't writing it, I was kind of just like listening.
Yeah, yeah.
So I'll just rewatch it.
You sure?
Yeah, yeah.
Okay,
Thank
that's
you
good.
though.
Yeah, no worries.
Bye.
Bye.
Thank you. Goodbye.
Okay, see you later, Lucas.